Good afternoon, everyone. Welcome back. Yes, how was your day yesterday? Good. Yes. Yes. A very good afternoon. Om, Mehak, Asha, Jignesh, Harshita, Amit, Janhavi, Apurva, Pavitra, Shreya, Anjali, Vidushi, Rohani, Navya, Deepika, Amar. A very good afternoon to all of you. Yes. So today and the next time we are going to talk about theoretical distributions of probability. Okay. So if you remember, oh my, so many more. Yes. Venkat Lakshmi, Chanchal, Bhumika, Swati, Amrit. Very good afternoon to all of you. Yes. Yes, Om, thank you for your colorful and beautiful good afternoon. So if you remember, like when you, I think sir took your measures of central tendency. So there you have, you made a table, right? Where you wrote about X, the values that the variable X is taking. Then you talked about the frequency of that value of X. And then you made the chart, and then on that distribution, that is known as the distribution, frequency distribution, and on that frequency distribution you applied the formula, and then for the distribution you found out what the mean is, what the mode is, what the median is, what is the variance, what is the standard deviation. Okay, all those things you remember you've done. Similarly, now what we are going to do is we are going to make a probability distribution similar to that on the same line. But here remember, the sum of all probabilities is going to come to be equal to 1, right? Just remember that when I'm making a frequency distribution, it's there is no such condition, but over here you have this condition. Then we are talking of theoretical distribution because we are using a formula and then we are trying to find the expected. Okay, so that is why it is a theoretical distribution. Yeah. Now, we may think of a probability distribution like distribution of total frequency in different classes. The total probability, like in this case, total probability will come to 1 to different mass points in case of discrete random variable, or to different class intervals for a continuous. Okay, so I may have a discrete RV. Okay, a random variable is represented by RV, so it may be discrete. What does discrete mean? That it is countable, 1, 2, 3, 4, and continuous. There is a you define a range. Okay, so either a discrete or to different class intervals in case of continuous random variable. So you may have continuous random variable, or you may have discrete random variable. Such a probability distribution is known as a theoretical probability distribution. Why? Because this distribution exists in theory only. Actual, when we are doing like the actual results, there may be a variation from the theoretical results. We need to study the theoretical probability distribution for the following important points. So why do we need it? The FD, the frequency distribution, gives us the number of times. Okay, very important. Number of times a data point occurs. Okay. So what does my frequency distribution gives me? It gives me the number of times a data point occurs. Okay, so for example, if I have the value of X is equal to 0, 1, 2, and then I say the frequency is, okay, let me put it 10, 11, 12. Okay, let me say that these are the marks students obtained. So how many students obtained 10 marks? So I'm saying 5, then 4, and then 3. What does this mean if frequency distribution in frequency? What does this 5 mean? It means there are 5 students scoring 10 marks each, right? Remember? Okay. So this 5 over here represents the number of times a data point. What is the data point in this case? 10 occurs. But in the probability distribution, it gives a probability that the data point will occur. Okay. It will give probability that this will occur. Means if I say the probability of getting a 10 marks is 0, means what? That marks will not be there. Okay, so that is the probability distribution. It is used to predict the short-term projections for the future. Okay. Simple thing, just trying to warm you up to the idea of like applying what you have already learned in measures of central tendency to probability distributions. Yes, Sakshi, good afternoon. Vaidehi, good afternoon. Prem, Sartaj. Okay, Mohammed Sartaj, welcome to the class. You can always watch the earlier sessions videos. Okay. So first is what is the important point for theoretical probability distribution is that the frequency distribution gives us the number of times a data point will occur, whereas the probability distribution gives us the probability that that data point will occur. Second is it is used for short-term projections. And third is that statistical analysis is possible only on the basis of theoretical probability distribution. Okay, so where do you use it? You use it for statistical analysis. Setting confidence limits. Okay, so this is maybe we'll be taking up in next class. Okay, testing of hypothesis. I don't think testing of hypothesis is there in your syllabus, but these are all statistical measures, you know, for for data validations purposes. Okay, so setting confidence limits or testing statistical hypothesis about those of you who have missed out on those class, or like, you know, you just go through the study material, or you can watch earlier videos also, this year's and earlier batches videos also. Okay, so you can get a fair idea of this. Again, a probability distribution may be either a discrete probability distribution or a continuous probability distribution depending on the random variable. So we talked about random variable. We talked with that it can be a discrete variable or it can be a continuous one. So for a continuous one, how do I go about it? I put in class intervals. Okay, so using class intervals, I can do that. Two important discrete probability distributions are binomial distribution and Poisson distribution, and continuous one is normal. There are many more, but for us, at least we should know. Okay, so they may ask you like what is Poisson distribution, whether it's a discrete, whether it's continuous. So you should know that. So applications of binomial distributions are, binomial distribution is applicable where the trials are independent. Okay, so whenever you have independent trials and each trial has only two outcomes, success or failure, then you can apply binomial distribution to such cases. In this, that independent trials and two outcomes are there, either a success or a failure. Where do you apply? For example, apply to the coin tossing. Okay, so I flip a coin, I can get either a head or a tail. Okay, you may say I may get more than one head when I have 2-3 coins. Fine, but the basic building block is what? One coin has only two options. Okay, so either I can have a head or I can have a tail. Sampling inspection plant. So in sampling inspection plant, what you can have, either you have a defect or there is no defect. Okay, so this type. Okay, like if this is taking place in a factory which produces bulbs, so you can have two, either the bulb is working or it is not working. Okay, and the next is genetic experiments. So you can have that, in that you can have this kind of thing. Okay. So you have the theoretical distributions. So you have, in that you have the discrete or you have the continuous. So discrete probability distributions, we are talking of two types, binomial and Poisson, and the continuous, we are talking about the normal distribution. Okay, somewhere you may read. So I'm just telling you this. All this, this is based on the Bernoulli trials. Okay, so what does Bernoulli trials say? That if you if you're doing an experiment which is independent, okay, so that is the if I do many trials, okay, like flipping of the coin. When I flip the coin for a second time, does it depend on whether I had a head or a tail earlier? No, it does not. It will depend only on that. Okay, so when I'm flipping the coin, it will be independent of earlier trials. Okay, so that they are identical. That is, when I'm flipping, it is unbiased. So okay, so whenever I flip, there is 50-50 chance of getting a head or a tail. So it is independent, it is identically distributed, and outcomes are 0 or 1. So either I will get a success or I will get a failure. There is no third option, and it is a discrete time stochastic process. Okay, so that is, it's all random variable based. Okay, so this is, first is Bernoulli trial, and based on that you have the binomial distribution. Okay, so this is only there for your information. I don't think you'll get a question, but it is my duty for you to tell that all these distributions, the basic is the Bernoulli trials, which are saying that the trials are independent of each other. The trials are identical. The trials will give rise to either a success or a failure. Features of binomial distribution are each trial is associated with two mutually exclusive and exhaustive outcomes, the occurrence of one of which is known as success, and as such, its non-occurrence as failure. Okay. So, and success and failure does not mean the simple English word. Like if I'm saying, what is the chance of the tire bursting on a very hot road? Okay, so if I'm traveling from Rajasthan in peak May June, what is the chance of the tire bursting? So tire bursting is a success. Okay, if I'm trying to do that experiment. Okay, so it is not only the English, it is depending on what I want as a success. And okay, why would I want the tire to burst? No, that is the tire company is trying to find out what is it that we should do so that the tires will not burst. Okay, so success does not mean only positive. It can mean a negative thing also happening can be a success. As an example, when a coin is tossed, usually we say the head is a success and its non-occurrence, tail is a failure. But that is the usual way of saying. I may say that tail is a success. Okay, nobody is stopping me from doing that. But that is the normal norm. We always say, like even in Sholay, movie Sholay, we are talking about head and tail. Excuse me. The trials are independent. The probability of the success. Okay, yes. The probability of the success is denoted by small p. And what will be the failure? 1 minus p is denoted by q. Because what I know is there is only two outcomes. Only two outcomes. Success and failure. Okay. So I have only these two. So this is my probability of success. This is my probability of failure. This is equal to 1. Okay. The number of trials is finite positive integer. Okay. So the number of trials is finite positive integer. So we are not talking about infinite this thing. We are talking about finite. So what are we, when I'm talking about features of binomial distribution, we are saying each trial has two mutually exclusive exhaustive outcomes. Okay. MEE. Right from last time we are talking of MEE, mutually exclusive. Means what? One is not dependent on the other. Exhaustive means out only these two will be the outcomes. There cannot be a third outcome. So it is exhaustive. There is no other thing that can happen. Okay. Then you may have a success or a failure. That is the only options that you have. Then if I denote the success probability of success with P, I will small p, I will denote the probability of failure as small q. P plus q should always be equal to 1. And the number of trials is a finite positive integer. There are n independent trials. Each trials can result in okay, sorry, by mistake there. 2 times a result in either a success or a failure. Only one of the two possible outcomes. Okay. So probability of success is equal to P is a constant from trial to trial. Probability of failure is 1 minus P. X represents the number of success in n trials. Okay. These are the 2 questions I want you to quickly answer. Just put it in the chat box. What will be the answer? Okay. So, a trial is an attempt. What is a trial? A trial is an attempt to make something possible, make something impossible, prosecute an offender in court. That is happening in the subject of law. But here it is a produces an outcome which is neither certain nor impossible. Okay. When we are talking Bernoulli trial, as we see, characteristics of Bernoulli trials are okay. So that is why I have talked about Bernoulli trials. Is that trials are what they produce an outcome which is neither certain nor impossible. The important characteristics of Bernoulli are each trial is associated with just two possible outcome. True. So this is true. Trials are independent. Yes, that is also true. Trials are infinite. No, this is not true because we are saying trials are finite, right? So what is the option? B. Both A and B are correct. Is that clear? Yeah. Excellent, excellent. 7, Asha, not 7A, 7D. Arshita? Okay, this is very typical definition of trials in statistics. That is the English word, okay? Making something possible. Yes, Samreen? It is D. Yes, both A and B. Very good. Venkat Lakshmi also, Ritu also. Yes, Asha now clear. Tina, Bhumika, correct. Shoaib, correct. Khushi, correct. Yes, Samreen, correct. Oh, there are 2 Khushis. One with a double E, one with a I. Yes, Farah, Pratima, Vidisha, Dhruv, Harshita, Shamya, Asif, Suryansh. Suryansh, 8, B is correct, right? But A is also correct. So the option D is the correct option, okay? That also very careful you have to be with foundation exam is that more than one if there are written, just make sure you're checking all the options. Yes, Palak, Pratima, Swati, Varun, Navya again the same thing. Both A and B. B is correct, no doubt about it. Vaishnavi, yes, again Vaishnavi, A is correct, but and B is also correct. Parth, same problem. Ruhani, correct. Saloni, Khushi, yes. Okay. Apurva, what was point C of Bernoulli? Bernoulli, it is a discrete time. So we like, it's not a continuous thing. You can count the number of trials and you can count the variables. Okay. Discrete variable. Rudra, we always practice questions over here. Okay. I think this maybe it's your first time today. Yes, Chanchal. Okay, Swati, you already learned about testing hypothesis. Very nice, very nice. Okay. So that is about Bernoulli. Bernoulli is talking about independent, identically distributed. The trials are independent, identically distributed. The outcomes are either 0 or 1, that is success or failure. And third is, it is a discrete time stochastic process. Then we are talking about binomial. Binomial says that you have a mutually exclusive and exhaustive outcomes where you can have a success or a failure, and then if P is the probability of success, 1 minus P will be the probability of the failure. Okay, always remember the number of trials in this case is finite positive integers. Formula. A discrete random variable is defined to follow binomial distribution with parameters n and p. Okay. Now, the related to your sums that you are doing, those formulas we are going to take now. So, a discrete random variable x is defined to follow a binomial distribution with parameters n and p to be denoted by x by this as b and p. Okay. So, you write it as b and p, which is binomial distribution where n is the number of trials and p is the probability of a success. Okay. So, and how do we write it? We simply write it by fx. Fx is equal to ncx. What is this? This is a combination. Okay. That's why I was always telling you that you should know probability, you should know set theory, and you should know permutation and combinations. Okay. ncx p raised to x, q raised to x for x is equal to 0, this is 0, 1, 2, up to n. So can you see I have made it finite, okay, and will be equal to 0 for other value of x. Means what? If I have something like 1.1, this is not going to work here. Okay, we are going to talk about these discrete values only, and for others it will be 0. So fx is equal to ncx p raised to x q raised to x. What is n? N is the number of trials. X is whatever we want to find out. Okay, whatever is given. What is the probability of getting 4 heads? Okay, so that time x will be 4. P raised to q. P is the success and probability of success, and q is the probability of n minus x. Sorry. P raised to x and q raised to n minus x. Okay. So now this theory question. The probability mass function. What is this called as? Probability mass function. It is written as fx. Probability mass function of the binomial. Also check for what they are asking. Binomial distribution is given by fx is equal to p raised to x q raised to n minus x. Always whenever they are asking you the formula, what you should do is wherever there is space, write down the formula. Because once you start reading, you will get confused. What is the correct one? So what I will do, I will write this. Fx is equal to ncx p raised to x q raised to n minus x. When I write this, automatically there is no NCX over here. So this goes. Why? Because NCX is not available here. Fx is equal to NCX. Correct. Q raised to x? No. P raised to x. So this is also not correct. Why? Because it is not q raised to x. It is p raised to x. Fx is equal to NCX. P raised to x. Q raised to n minus x. Yes, this is the correct answer. I will just check. D NCX correct. P raised to n minus x. This is not correct. So this is also wrong. So therefore I get B as the correct answer. Now can you tell me about 10th? What will be the answer for 10th? Amar, it is the answer is B. Okay. Yes, Suryansh. Answer the 10th one. Okay, Harshita, there too. Harshita is also. Okay. Okay. That is why purposely I have taken the theory questions right now also, because what happens is you know everything, but the options are tricky. Okay, it's not a question of whether or you know it or not. Those are, especially with this chapter, they don't have very huge like formula like you have in correlation regression. You don't have like something like that. But what you have here is this. Okay, if x is a binomial variable with parameters n and p, then x can assume any value between 0 and n, any value between 0 and n both inclusive, any whole number between 0 and n both inclusive, any number between 0 and infinity. So 0 to infinity, this is not the case. Why? Because in the assumption itself, we have written the number of trials is finite positive integers. So that is why the D is automatically cancelled. Okay? Sorry. Now, what is the difference between A and B? They are saying any value between 0 and n. Here they are saying both inclusive. That is, x can take 0 also and n also. Is it true? Yes, x can take the value 0 also and n also. So, some of you have written B, some of you have written A. Is A correct? Yes, it can take any value between 0 and n. B, can it take both inclusive? Yes, this is also correct. And then we are saying C is also correct. So what should I mark? Okay, A is also correct, B is also correct, C is also correct. But there is a big difference, okay, which we don't realize, especially during the exam time. So I'm saying any whole number. Okay, why? Because it's a discrete. It is discrete. So C will be the correct answer. If you're not, see, even in the formula, we very particularly said, usually we tend to forget this. For some, this is not needed, right? But for theory, you should know this. Fx is equal to ncx, p raised to x, q raised to n minus x for x is equal to 0, 1, 2, 3. Okay, so you can see 0 is also included, n is also included, but is equal to 0 otherwise. Is equal to 0 otherwise means if it is not a whole number, it will not hold. And therefore, it can be any whole number between this. Okay. Okay, so we are talking about the binomial distribution. We are saying there are independent trials. We are saying you can have a success or a failure. Then we are saying that the formula fx is given by ncx, p raised to x, q raised to n minus x, where p is the probability of success and Q is probability of failure. Very important. P plus Q is equal to 1, which I will need many times in the by solving. Then we say that probability distributions are of two types, discrete and continuous. Discrete is again of two types, like what we have. We have is binomial and Poisson, and continuous you have the normal distribution. Okay. Okay, is it clear till now? Okay, just put it in the chat box whether it is clear or not. Yes, Samreen, correct. Dhruv, correct. Swati, Sakshi, Bhavani, Farah. Arpan, your answer is visible, but unfortunately the answer is not correct. Okay? Arpan, I can see your answer. Suryansh, Mohammed, incorrect. It is not infinite, right? Yes, Bidisha, correct. Chanchal, just put in the question here, okay? As we near 3 o'clock, just put it that time so that otherwise I'll again forget. Yes, Asha, clear? Okay, so Janvi and others also, their set C contains a lot of problems. Those are meant for you to practice for, and most of you have mathematics in your board exams, so it will be a good practice for you. But as far as this is concerned, exam is concerned, some that are requiring you to solve on paper and pen for a large space, those will not be asked, because the time limit is 1 to 1.5 minutes for per question. So some questions are not even possible. For some question, you have to make the table and do it. So to give you a holistic understanding, that is why everything is put in the studying material. But you should practice them once you have done set A and set B. Okay. Suryansh, IND stands for independent. Okay. Binomial distribution where the trials are independent. Okay. Amar is saying clear, Sahana clear, Asif is saying clear, Vidushi, Vaidehi, yes. Crystal clear. Apuru, and denotes the number of trials. Clear. Yes. Do MCQ based also, you can have MCQ based, but you can have bigger sums, now carrying 5 marks. But that is not the case for foundation. Yes, where the small part of bigger question can also be asked. Yes. Okay. Okay, so what are the important theory again? Always remember, n is always greater than 0, and p and q will be greater than or equal to 0. It follows that fx is greater than or equal to 0. Okay, so wherever you you may have fx to be equal to f of 0, that is, you put n is equal to x is equal to 0, 1, 2, 3. Okay, f of 1 plus f of 2 and very bad 2. It was looking as if it is going to fall down, plus so on up to plus f of n. Okay, and all this should together, whenever I am doing summation, this will be equal to 1, because the probability distribution, the summation will always be equal to 1. Binomial distribution is known as biparametric. Okay, this is also a very popular Theory question. By means what? By. Okay. By means 2. Okay. You remember like in variations of the leaf, so you had this type of thing. So by is 2. Parametric means what? Parameters. By 2 parameters. Okay. What are the 2 parameters? N and P. Okay. For a binomial distribution is a biparametric distribution with parameters N and P. Okay. This means if the values of N and P are known, the distribution is completely known. Then the mean of the probability distribution, binomial probability distribution, is given by mu is equal to NP. Okay. You can also write this as N into 1 minus Q. Sometimes you may need this, so you may also know this. Mu is equal to NP or mu is equal to N into 1 minus Q. Depending on the values of the 2 parameters, binomial distribution may be unimodal or bimodal. Mu 0. The mode of binomial distribution is given by mu 0, the largest integer contained in n plus 1 p. If n plus 1 plus p is not integer, n plus 1 p, and n plus 1 p minus 1 if n plus 1 p is an integer. Okay, I will show this in the diagram and tell you. We'll just read through and then we'll go to this. The variance of a binomial distribution is given by sigma square is equal to npq. So we have mu to be equal to np. That is, what does this mean? Then we have variance. What is the symbol? Sigma is equal to npq. Sigma square. Sigma is for standard deviation. Since P and Q are numerical less or equal, then NPQ will always be less than NP. Okay. So, you have mean is equal to NP and variance mu square is equal to NPQ. Always remember for binomial distribution. Okay, this is also a very popular theory question. Variance will always be less than mean. Okay, variance will always be less. There is a explanation given. You may read that, understand that, no problem. If even if you don't, you're not able to explain, doesn't matter, because in the exam they will only ask you this, that is this true or not? That variance of a binomial distribution is always less than its mean. Yes, it is always. Also, variance of x attains its maximum value when p is equal to q is equal to. Okay. So what happens is, this is a special case. If p is equal to 0.5, q will also be equal to 0.5. Okay, because q is 1 minus p, so it will also be equal to 0.5. What will be mu? What will be the mean? It will be 0.5 times n. What will be the variance? It will be n, that is n into 0.5 into 0.5. So this is equal to 0.25 times n. Okay. So they are saying the variance of x attains a maximum value. This is the maximum value. So mu square max is equal to 0.15 n, which is also equal to n by 4. Okay. So these are the things that you should know. See, you can always go and study and you may write it down also. But from the exam point of view, this session is from the exam point of view, wherein you just have to know what is important, what can be asked. So here I'm telling you that the maximum value for variance of a binomial distribution is equal to n by 4. Okay. And when will that happen? When both p and q are equal to half. Okay. So we are saying for a binomial distribution, mean mu is equal to n into p, variance mu square is equal to npq, and variance will also always be less than mean. Okay, so what are the important things here? This is the first, this is the second, this is the third, this is the fourth. Okay. So mean, variance, formula for mean, formula for variance, then the condition that variance will always be less than the mean. Then fourth is when will the variance be maximum? When P is equal to Q is equal to half will be the condition. Okay. And then we are going to talk about the mode, because here we have given that depending on the value of the two parameters, binomial distribution may be unimodal or bimodal. This is a very unique feature of binomial distribution. Usually it is a unimodal or a bimodal or a multimodal. So here it will depend on what is the value of the variables. So have you understood? Yes, Mohil Kumar, you can take the calculator, but you have to take the non-scientific calculator, okay? The calculator which only has up to percentage and the square root, okay? So you can take that. Yes, Bhumika, you must practice all that is given in the study material as far as possible. If not, at least the AB exercises have to be done completely. आयुष, याद नहीं करने आपको, आपको सब सॉल्व करने हैं, क्योंकि वैसे के वैसे पूछते नहीं है, जैसे बोर्ड एग्जाम में पूछते हैं ना, उस तरह से क्वेश्चन नहीं आते। यहाँ अलग अलग टाइप के क्वेश्चन आते, तो आपने 2-3 बार उस टाइप के क्वेश्चन रिवाइज कर लिए, आपने मॉडल क्वेश्चन पेपर सॉल्व कर लिए, आप मॉक टेस्ट में जाइए, बैठिए, तो आपको आइडिया आ जाएगा कि आपका स्पीड ठीक है कि नहीं. So the most important thing is for you to appear for your mock exams. There are very good way for you to understand whether the timing is enough for you, the speed with which you are solving the question, whether it is enough or not. So always, whenever the branch is organizing mock test, you will get the message. You should go to the WRC website or the knowledge portal and see when the mock test, online mock test, whether they have been conducted, or offline in your branch if it is conducted. Do go and attempt. Okay. Asha, you can attend in any order that you want, but make sure you are attending properly, the question, like you have to circle the on the different sheet of paper. Just if you move one question, एक क्वेश्चन ऊपर नीचे हो गया, तो आपका क्या हो जाएगा, आपका आंसर सब गलत हो जाएंगे. तो if you are attempting in between the questions, just make sure. Okay, and even when you're skipping some questions, make sure you are seeing the question number in the question paper and in your answer sheet, whether they are matching or not. Also, be very careful with that. Yes. Vidisha, by means 2. Yes, Om, crystal clear? Palak, it is up to you. You try to practice as much as you can. Now we were talking about mode. So for mode, it's a very different thing. For mode, you don't just put in a formula and get it. For that, you have to test. What do you test? You should test the value of n plus 1 into p. I take n plus 1 into p. This is p. Now this value may be an integer or may not be an integer. If it is not an integer, then take the largest integer. Suppose this, I have 3. If my n is equal to 3 and my p is equal to 0.29 or 30, if this is 30, then I will have what is n plus 1? 3 plus 1 into 0.30. 3 plus 1 is 4. 4 into 0.3 is 1.2. 3 plus 1 is 4. 4 into 0.3. Is it an integer? No, it is not an integer. Then we say mode will be the largest integer. What is the largest integer here? Largest integer is 1. So what will be the mode? Mode will be equal to 1 in this case. Okay. So you have to find out n plus 1 into p and then decide. What will happen if n plus 1 is an integer? If it is an integer, it will be bimodal. Here there will be one mode. Okay, that is a best, very different, part of binomial distribution. So what if I want to find the mode of a binomial distribution? So I must first check what? I must first check n plus 1 into p. What if it is not an integer, this multiplication n plus 1 into p? Then the answer is simple, that you have only one mode. What will that mode be? Only the integer part of the fraction. Okay. So here it is 1.2. I will just take 1. That is the integer part. And then I will say mode is that. What will happen it is, if this is a number, if n plus 1 p is a whole number, it is an integer, then you will have two modes. Which will those two modes be? N plus 1 into p will be one mode, and the second mode will be n plus 1 into p minus 1 will be the second mode. Okay. So there is a lot of, study that and research gone into all this, but we are lucky we just have to use the formula. Okay. So just make sure you have written all this down. All of this is in your head. Pallavi, online mock test, the institute, you should visit whichever area, like if you're belonging to WRC, then the WRC website is there, or Central Students CIRC, okay? So you visit that website, go to the student section, see, what are the important circulars, important points that are given, news that are there, and there you will be able to know. You can also call your branch and ask them if that is going to be done, or you can contact directly to WRCW or any region that you are. If you are in south or north, anywhere, you can just call them up and ask them when tentative date, and then just make sure you're visiting the website regularly to be able to understand. And I think now on the app also, there's so a lot of things are there. You can explore the app. That will give you huge number of good information is available over there. Okay. Yes. So I hope now mode has been understood. We'll be doing the sum, so don't worry. Now, see, today I'm taking the theory questions along with this so that you can score marks in these topics. So what is it? An example of biometric discrete probability distribution is, so biometric. So binomial is a biometric probability distribution. Why the other two not? Because once you know, then you'll know about the others also. So for here, the answer is binomial. Okay. Then a binomial distribution is never symmetrical, never positively skewed, never negatively skewed, symmetrical when p is equal to 0.5. Okay, have I written about skewing here? Just let me check. Okay, I have not written, so I'll just tell you the answer here itself. Okay, a binomial distribution is always positively skewed. Okay, it's positively skewed. Now, never symmetrical, out of question, it is symmetrical. It is not like it is skewed. So, never positively skewed and never negatively skewed. Okay, so never when it comes now, it becomes difficult. Okay, never positively skewed means what? What does this mean? It means negatively skewed. Never negatively skewed means what? It is positively skewed. Symmetrical when p is equal to 0.5. So when positively skewed, yes. binomial distribution is always positively skewed, so you will have C as the correct answer. Here, what is happening? Already the concept is tough, and on top of that, they have given options in the negative. So it will be never positively skewed, never negatively skewed. So it is never, it is positively skewed means it is not negatively skewed. Okay. Negation of a negation. I think you must have done it in your 12th, you know. What was the chapter? You have to do all this negation of negation, assumptions and all. Okay. So this is the answer. Now, can anybody now answer? Like you can put it in the chat box. 16th and the 8th. The mean of binomial distribution is, and the mean of binomial distribution is here. In the second one, they are asking you the formula. In the first one, they are asking you the relation between mean and variance. Okay, this is asking you about mean and variance. Yes, quickly put it in the chat box. Wonderful. So many people are answering so well today. Okay, Chanchal, there are two Chanchals. We'll have to see how many names are there, which are two. So right now we have Harshada, you have Harshita, Khushi, Chanchal. Skewed means what? Skewed means it is bending towards a particular direction. Okay, yes, okay, so you don't know what skewed is? So when I'm saying rightly skewed and left, right or left, okay, left, right, which is also called as positive, and this is called as negative. I have a graph. In one graph, I have something like this, and I have another graph which is like this. This, where the tail is going, okay, where is the tail going? To my right. This tail is going to my right, so it is saying rightly skewed. माने उस तरफ झुका जा रहा है वो. And this is going towards my left, so this is left or negatively skewed. Okay? अपूर्व समझा? So good now. See, once you are paying attention, I'm so glad everybody's got these answers correct. The mean of a binomial distribution is always more than the variance, okay? Because there I had written variance is less than mean, but now I'm so glad you can make up. Once you know one thing, you should be able to talk about the other also. Mean is, variance is always less than mean means mean is more than variance, okay? Mean of a binomial distribution is given by n into p, okay? Yes, Vidisha, Vaishnavi, Janvi, Bhavani, Roshan, Kushi, Deepika, Ritu, please see the instruction that I've given, okay? I cannot tell you whether it is the black pen or a blue pen, okay? Just make sure you are reading all the instructions that are coming with your admit card, okay? I think you'll get the admit card online. And when you download that, just make sure there is always the important instruction for the candidates. Make sure you read that, okay? Yes, Vaishnavi, there are two Vaishnavis also. Sarta is not equal to its variance. It is, mean is always more than the variance. Ardhindu, then Mohammed, then Chanchal, Arpan. Okay, Arpan and Payukta have answered. The next one, the mean of a binomial distribution with parameters n and p is given by. The mean is given by C. Well, C. The variance of a binomial distribution with parameters n and p is given by NPQ. Okay, yes, this is what I was trying to tell you. NPQ. Now what happens is the variance is given by this. Now, can I have a square root? No, square root is happening for standard deviation, so not variance. Okay. Now NPQ. Here nowhere. Here both are P. Here they both are P. Here both are Q. Here they both are P. Now I must see that I know variance is NPQ, which can be written as N into P into 1 minus Q, 1 minus P. For Q, I can write it as 1 minus P. Or NQ 1 minus Q. Okay. You have to see which of these is holding NP 1 minus P. And this is P square. Okay. So this is not true. This is already not there. NQ. NQ 1 minus Q. Yes, this will hold. N square P square. No, this is not holding. NPQ. Okay. So has everybody got this answer? Excellent, excellent. Rohit, you have to first fill the admit card. Fill the fees and form for exam. Only then you get the admit card. Okay. Okay. We'll do these 4 questions and then we'll take the break. Okay. I understand you get tired. For a binomial distribution, mean, median, mean and mode are never equal, are equal when q is equal to 0.5, are always equal, do not always exist. 15th question. Are always equal is not the case. Do not always exist is also not the case. So these two are out of question. Now we are left with A and C. Q is 0.5. When Q is 0.5, what will be P? P will also be 0.5. Okay. So what will happen is, what will be mean? N into P, which is equal to 0.5 times N. 0.5 times N. Now, what about mode? For mode, I must find out N plus 1 into P. Now, what is N plus 1 into P will be N plus 1 into 0.5. Okay, N plus 1 into 0.5. So, we first find this and then we find whether it is an integer or not an integer. Okay. When if this is not an integer, what will happen? We will take only the integer part. Okay. Now, if I have n plus 1 into 0.5, this will be equal to 0.5 times n plus 0.5. I expand this bracket. So, this portion will go away and what will it have? 0.5 times n. Okay. So, it will have 0.5 times n. If this becomes an integer, no problem. Then you will have this. So, this is equal when q is equal to 0.5. Okay. 16th, the mean of a binomial distribution is always more than the variance, always equal to variance, always less. So, mean is always more than the variance. Okay, there is no equal to, it's always more. So it is always more than its variance. For a binomial distribution, there may be one mode, two modes, multi-modes, A or B. Okay. So for 17th, what will be the answer? A or B. Okay. Depending on whether it is a integer or not. The maximum value of variance of a binomial distribution with parameters n and p is n by 4. Okay. We have done that. Okay. Where have we done that? Here. If p is equal to 0.5, q is equal to 0.5, mu is equal to this, and sigma square max is equal to n by 4. Okay, so variance is maximum of n by 4. Okay, for the 15th, let me explain with an example. Okay, 15th question. Let n be equal to 5. Okay, then we are saying q is equal to 0.5. Then p will be equal to 0.5. Okay, we know 1 minus q is equal to p. Then we will check n plus 1 into p. This will be 5 plus 1 into p, that is 0.5. So 6 into 0.5, answer is 3. Okay, when you have an integer, there will be two modes. Two modes. Which are those two modes? N plus 1 into p and n plus 1 into p minus 1. What is n plus 1 into p? Is equal to 3 and this is equal to 2. Okay. So, you have, and mean is equal to n into p. N is 5 into p is 0.5, which is equal to 2.5. Okay. Correct. Then you have, let n be equal to 6, q is equal to 0.5. Then it will be what? This will be equal to, mean will be equal to 3. And what will be the mode? N plus 1 into p is 7 into 0.5, which is equal to 3.5. Okay, for this is a test. Okay, so when I am testing, this is not an integer. So what will be the mode? Mode will be equal to 3. Okay, I think it's already 3 o'clock. Yes. Break, Leila. binomial distribution, there may be, see, is it multi-modes? It is not multimodal. Multimodal means what? You will have something like this, like this, then like this, then like this. This is multimodal. Here you may have one mode or two mode depending on whether n plus 1 into p is an integer. Okay, so therefore the answer is A or D. A or D. Okay, so either I get directly one mode or I get two modes. Now for the 15th question, they're equal because here it is symmetric. Let me just show you over here. Okay, if I have here, we were talking of n is equal to 5 and p is equal to q is equal to 0.5. Okay, now what I do is n plus 1 into p. So 5 plus 1 into p. What is this? 5 plus 1 into p is 6 into 0.5, which is equal to 3. Is it an integer? Yes, it is an integer. What will the modes be? 3 and 2. Okay, so modes will be 3 or 2. Okay. Okay, so that is why the answer for 17th is D and for this is C. Okay, and one more question there was somebody was asking. Okay, now here this is also correct and this is also correct. It is symmetrical when P is equal to 0.5. So let me see. Okay, so these two are correct. Usually that will not happen, but in this case, this is true. And don't worry, in the exam, you'll get just clear one answer, which is clear. The discrete random variable x is defined to follow a binomial distribution with parameters n and p. We are talking about the formula fx is equal to ncx, p raised to x, and q raised to n minus x. Okay. Also, Chanchal, have you sent me the question? Yes, Bidisha, it is not that way. Mohammed, you have to go to the ICI where LCC lectures are there. Over there, the PDFs have already been uploaded. Whatever we do today, the PDF is there. So you can always follow from there. Okay. Okay. So this is the formula we'll be using. Now let us do the sum. If x is a binomial variate with parameters 15 and 1 by 3. Okay, so obviously 15 cannot be the probability. So this is n is equal to 15 and p is equal to 1 by 3. What is the value of mode of the distribution? Okay, so you have to be just careful that we are talking of parameters. Parameters for a binomial distribution are n and p. So this is the value of p that is given, not q. Okay. Now what we have to check, we know that mode of binomial distribution is given by n plus 1 p. This is the check. If this is an integer, I have two modes. If it is not an integer, I will take the largest part. Okay, so let me do n plus 1 into p is equal to how much? 15 plus 1 into p, 1 by 3. So this is equal to 16 upon 3, which is equal to 5.33. Okay. So what is this? This is not an integer. So integer. So mod will be equal to 5. Okay, only the integer part. So mod will be equal to 5. So B will be the correct answer. Has everybody understood this? Yes, crystal clear? Yes, Mohammed. It's easy to understand. Yes. Vaishnavi, usually you will not have that two answers are correct and only one is written over there. Okay. Yes, Prem, Om, Arpan, Harshita. Yeah, very good. Next, we are taking this one. Example. What is the mode of the distribution for which mean and standard deviation are 10 and root 5 respectively? Okay. Yes. Hmm? First, let us find out this. We know formula for mean is what? N into P. Standard deviation is equal to square root of NPQ. How much is this? 10 is equal to N into P. Standard deviation is how much? Root 5 is equal to square root of NPQ. Okay. Now instead of NP, what can I write? I can write 10. So root 5 is equal to square root of 10Q. Root 5 is square root of 10Q. Squaring both sides. I have 5 is equal to 10Q. Q is equal to 1 by 2. Therefore, P, which is equal to 1 minus Q, is also equal to 1 by 2. Okay. So P is 1 half, Q is also 1 half. Now I have the value of P. I know mean is equal to 10 is equal to N into P. 10 is equal to N, I don't know. P I just found out to be half. So N will be equal to 10 into 2, which is equal to 20. Okay. Now I have the value of N. I have the value of P. Let me test. Test for mode. N plus 1 into Q. N plus 1 into P. Sorry. Q. N plus 1 into this is equal to 20 plus 1 into P. P is 1 by 2, which is equal to 21 into 0.5, which is equal to 10.5. Okay. 10.5 is not an integer. So mode is equal to 10. Has everybody understood this? Yes, Nancy, clear? Apurva, clear? Yes, Suryansh, mode. See, mode is not 10.5. We are just finding the value of n plus 1 into p. Okay. That is the value. Okay. Prem is, answer is 10. Very good. Rohani clear. Arshita clear. Om clear. Yes. Everybody is now clear with this answer? Excellent. Let us go to the next one. Okay, yes, this is also a very important property. This is called as the additive property. Okay. Additive property says what? If I have a binomial distribution with parameters n1 and p, and I have another binomial distribution with parameters n2 and p. So the p is same, but one has n1 and the other has n2. Suppose like I am doing this for a class, this finding a binomial distribution for a class saying students pass or fail. So either they have passed or they have failed. We are not talking about the marks. We are just talking about whether they have passed or failed. So I do it for division A and I also do it for division B. Okay, criteria is the same. Passing of the exam. So in class division A, I have maybe 60 students, and in class B, I may have 63 students. Okay. So when I have two binomial distributions, they are saying that we can have an additive property. Means I can use this and I can club them together. Okay. So that I am able to talk about 123 students. Okay. That is the best part of binomial distribution because it has an additive property. So if x and y are two independent variables such that x is equal to n1p and y is equal to b of n2p, then x plus y will be n1 plus n2 into p. Okay. So you will have then b is equal to, you'll have n1 plus n2 and p. P is a probability of success. Okay. We'll take an example, it will become clear. If x and y are two independent binomial variables with 6.5 and 4.5. Okay. So I have for fx, what is it? B of 6.5. And for y, I will have b of 4.5. Okay. So n for first is 6 and for other is 4. So let x plus y be equal to z. So what will happen here is you are asking x plus y is greater than or equal to 1. So this means what? P of z, which is greater than or equal to 1, is 1 minus p of z less than 1. Okay. So what is p of z less than 1 will be equal to p of x plus y, that is x plus y is 6 plus 4 and half, which is equal to p of 10 and half. Okay. So then this will be equal to 1 minus p of 10 and half. Okay. So less than 1. What does less than 1 mean? What can the value? For z less than 1, values will be 0. Okay, value will be 0. So what do I have? 1 minus f of 0 I have to find out. I have to find out p z. Okay, there is no place here. Let me write it properly. Okay, so what I have to do now is I must have p of z greater than or equal to 1 because it is greater than or equal to 1. Otherwise, I would have taken 1 also. Will be equal to 1 minus p of 0. Okay. What will this be? This will be p of 0 is equal to, what is n? N is 10. Okay. N is equal to 10 and p is equal to half. And so q is also equal to half. Then p of 0 will be equal to 10c0, 1 half raised to 0 and 1 half raised to 10 minus 0. Okay, 1 half raised to 0 and 10. 10c0 is how much? Can anybody tell me what is the value of 10C0? Yes, remember combinations? Bhumika, what do you want me to explain again? Just let me know. Yes, Asha has understood. Om has understood. Arpan has understood. Okay. Can anybody tell me what is the value of 10C0? 1? Okay, 1 into 1 half raised to 0. Any number raised to 0. A raised to 0 is always equal to 1. So this is into 1. Into 1 half raised to 10 is 1 half raised to 10. 2 raised to 10 is how much? 1 upon 1024. 2 raised to 10 is 1024. Now what do I have need? I need this. P of z greater than or equal to 1 is equal to 1 minus P of 0. What is P of 0? 1 minus 1 upon 1024. P of 0 is 1 upon 1024, which is equal to 1024 minus 1 upon 1024, which is equal to 1023 upon 1024. Okay. So what will be the answer? So whenever this is greater than, it is always better that you change it into less than. Okay. Not, it is not always we need to do it, but as far as possible do it, because otherwise what you would have done here, you would have calculated for 1, 2, 3, 4 up to where? Up to 10. Okay. So this is better. If I just do 1 minus that, I will get the same answer. Saloni, not 10 factorial. Okay, okay. Please don't get confused. NC0, where n is any number, is n factorial upon 0 factorial into n minus 0 factorial. Okay. N factorial is n factorial. 0 factorial I know is equal to 1. Okay. Always remember 0 factorial is always equal to n. 1. N minus 0 is what? N is equal to n factorial. So 1 into n factorial. So n factorial cancel out 1. So anytime you have NC0, answer will always be equal to 1. Yes, Swati, correct. Janvi, correct. टीना, 0 किसका वैल्यू है? नहीं, उन्होंने क्या पूछा है? देखो क्वेश्चन में लिखा है, उन्होंने पूछा है हमको क्या है, P ऑफ Z greater than or equal to 1. वो क्या बोल रहे हैं, Z की वैल्यू कैसे चाहिए हमको? 1 या उससे ऊपर चाहिए. मेरे n कहाँ से है? मेरा n जो है, मेरा n 10 है. और मेरी x की वैल्यू, z की वैल्यू क्या क्या हो सकती है? 0, 1, 2, 3, 4 अप टू 10 ऐसे हो सकती है. तो अगर मैं z ग्रेटर देन इक्वल टू 1 वाला चाहिए मुझे, मतलब 1, 2, 3, 4 अप टू 10, तो इतना करूंगी तो मैं कर सकती हूँ. ऐसा नहीं मेरे से होगा नहीं, लेकिन मेरे को बहुत ज्यादा टाइम लगेगा और बहुत ज्यादा फिर मेरे को कैलकुलेशंस भी करने पड़ेंगे. उससे अच्छा मैं जब ऐसी चीज होती है तो मैं लिखती हूँ उसको 1 माइनस पी ऑफ z लेस देन 1. ओके. ये ग्रेटर देन और इक्वल टू साइन है ना, इसलिए उसको ऑपोजिट क्या होगा? z लेस देन 1. अब z लेस देन 1 माने z की वैल्यू क्या हो सकती है? सिर्फ एक ही वैल्यू हो सकती है, z लेस देन 1, 0. नेगेटिव वैल्यू तो है ही नहीं हमारे पास, और डेसिमल्स हम लेते नहीं है, तो मेरे पास एक ही इंटीजर वैल्यू बचती है, वो है 0. तो इसीलिए मैं कैलकुलेट करती हूँ 1 माइनस पी ऑफ 0, है ना, z इक्वल टू 0. z इक्वल टू 0 कैलकुलेट करती हूँ तो मतलब मैं वहां पे जो मेरा फॉर्मूला है एफ एक्स का, बाइनोमियल का, जो एफ एक्स का है वो मैं एफ जेड को लिखती हूँ एन सी जेड पी रेस टू जेड क्यू रेस टू जेड माइनस 1. ओके, ऐसा रहेगा. क्लियर है आप सबको? हाँ. भवानी 16 विदिशा 16.9. Tina, now I hope you've understood. Bhavani, have you understood? See, what has happened here? Let me again explain. Is the place? Yeah. Let me explain this sum again. 6.5 and 4.5. Okay. See what happened? I had a distribution. Okay, let me call that with x and f of x. What was happening here? It was what? It was a binomial distribution with 6.5. Okay. And then I had another binomial distribution with 4.5. Okay. We are using the additive property. We are saying x plus y is equal to z. Okay. We have these two binomial distributions and we are combining them and saying x plus y is equal to z. But what they want, excuse me, what they want is that they want p of z greater than or equal to 1. Okay, if this is my timeline, if this is my line, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. When I'm saying z greater than equal to 1 means what? From here to here, I want the value of that binomial distribution. Now, to find this, what will I have to do? This is equal to f of 1 plus f of 2 plus f of 3. कहाँ तक? F of 10th. Okay. Instead of doing that, what I do is I write, this is my total. And what is the probability? Total probability. Total probability is always equal to 1. Everybody remembers that. Okay. Total probability is always equal to 1. So from this, I want only this. Okay. From this, I want this. So what will I do is, I will just subtract this. From this, I will subtract this. What will I get? I will get this. Okay, so instead of calculating all this, I am saying P of Z greater than or equal to 1 is simply, what is the total probability? 1 minus, what will I subtract? Only this portion, which is P of Z equal to 0. And when I do that, I get the answer as 1023 upon 102. Bhavani, have you understood now? Vidisha? Yes, Tina, Asha, crystal clear. Bhavani is understood. Okay, now the next question. A coin is tossed 10 times. Assuming the coin to be unbiased, what is the probability of getting 4 heads? At least 4 heads, at most 3 heads. Okay, here it is a very good question where the English is also equally important. Okay, what we are talking. See, when I'm saying getting 4 heads, getting 4 heads means I only want 4 heads. कम नहीं ज्यादा नहीं सिर्फ 4 heads चाहिए. एटलीस्ट 4 heads. एटलीस्ट वर्ड आएगा तो इसका मतलब 4 दो अच्छा है लेकिन 4 से ज्यादा दो तो भी अच्छा है. Okay, if you are like if you are saying somebody asks you how many gems do you need, after like somebody is offering you gems, how many gems do you need? You will say at least 4. So what does it means is either you give me 4 or you can give me even the whole packet of gems, right? I will be happy about it. So 4, at least 4 means उससे कम तो मुझे नहीं चाहिए, मेरे को उतने तो चाहिए. So at least 4 means what? It is up to 10. So at least 4 heads means 4, 5, 6, 7, 8, 9, 10. Okay. Again, here what happens is either I do this, I calculate 4, 5, 6, 7, 8, 9, 10, or I may do 1 minus z less than or equal to 4. Okay, this is also less than 4, not less than equal to less than 4. Okay. At most 3 heads. At most means what? Maximum. ज्यादा से ज्यादा मुझे कितने heads चाहिए? 3 चाहिए. What are the maximum heads that I need is 3. So what will happen? I will be having a situation 0 heads plus 1 head plus 2 heads and plus 3 heads. All these is going to satisfy the condition at most 3 heads. Okay. And this is a formula we'll be using. Okay. Is the question clear? What are the different options there that are there? Ina is saying clear, Bhavani is clear, Sakshi clear, Dhruv clear, Arpan now clear. Okay. Vidisha understood, Amar clear, crystal clear. Vaidya is saying yes. Okay. Yeah. Now the concept is clear. Now once I know the concept, I can do it. So for the first part, 4 heads. Okay, let me do it here. 4 heads I think I can fit in here also. 4 heads means what? X is equal to 4. Yeah. This is my function. So f of 4 is equal to, what is n? Okay, here. N is how much? 10. P is how much? It's a coin. What for a coin? It is 1 by 2. Okay, I can get a head. Okay, and Q will be equal to 1 by 2. For a coin, success is getting a head. Okay, success is getting it. So n is 10, p is half, q is half. So x is equal to 4 is 10c4, p raised to, not p, what is it? P is half, na? One half raised to 4 and 1 half raised to 10 minus 4. Okay, because p raised to x, q raised to n minus x. Okay, so what will I get? F of 4 is equal to 10c4 is 10 factorial upon 4 factorial into 6 factorial. Okay, 4 factorial and 10 minus 4, which is equal to 6 factorial. Okay, into 1 half raised to 4, 1 half raised to 4, and what is this? 10c4 is 1 half raised to 6. You remember a raised to m into a raised to n is equal to a raised to m plus n indices. So this is going to become, what is this? 10 factorial upon 4 factorial will be equal to 7 into 8 into 9 into 10 upon 24 into 1 upon 2 raised to 10. Okay. 024, because 2 raised to 10 is 1024, 7 into 3 is 21, 21 into 10 is 210 upon this thing. Okay. First question understood? At least 4 head we will do now. So this portion I hope you've understood. Sneha, doesn't matter if even if you're seeing the recorded thing, you can still enjoy mathematics. Okay, yeah, it would have been great if you could have attended live sessions, but it's so good whenever it is possible for you, you are attending. Yeah, thank you so much. Now let us do at least 4 heads. Second part, at least 4 heads means f of 4 plus f of 5 plus f of 6 plus f of 7 plus f of 8 plus f of 9 plus f of 10. Okay. Which is also equal to 1 minus f of 0 plus f of 1 plus f of 2 plus f of 3. Okay. So either I calculate directly or I can calculate like this. Okay. Now, first for this, I will have to calculate all the 4. So f of 0 is 10C0 half raised to 0 into half raised to 10. Okay. Because 1 half raised to p raised to x, q raised to n minus x. So this is equal to 10C0 is 1 into 1 upon 2 raised to 10, which is equal to 1 upon 1024. F of 1 is equal to 10C1, 1 half raised to 1 and 1 half raised to 9. Okay. So this is what 10C1 is how much? It is equal to 10 upon 1 factorial into 10 minus 1 factorial into 1 upon 2 raised to 10. Okay. This is equal to 10 upon 9 factorial, 10 factorial, and you will have this to be equal to, this is 10 factorial upon 1 factorial into 10 minus 1. 10 minus 1 is 9 factorial. That will cancel with the 10 factorial, 9 factorial, and you are left with only 10 upon 1024. Okay. F of 2 is equal to 10C2 into 1 half raised to 2 into 1 half raised to 8, which is equal to 10 factorial upon 2 factorial into 8 factorial into 1 upon 1024. Okay. So this is what 10 into 9 upon 2. 10 into 9 upon 2 is 45. Okay. 45 upon 1024. F of 3, 10C3, 1 half raised to 2, 1 half raised to, 3 and 1 half raised to 7, which is equal to 10 factorial upon 3 factorial into 7 factorial into 1 upon 1024. So this is equal to 10 into 9 into 8 upon 6 into 1 upon 1024. So this is 3 2s and this is 4s. So this is equal to 120 upon 1024. Now I have to add them up. So I'll try to do it here itself so that I don't have to change the page every time. What will be the value of F0 plus F1 plus F2 plus F3? What is this? 1 upon 1024 plus 10 upon 1024 plus 45 upon 1024 plus 120 upon 1024. Okay. Forty-five plus 1, 46, 46 plus 10, 56, 56 plus 120, 176. So this is 176 upon 1024. Now I am putting it over here. So at least 4 is equal to 1 minus F0 plus F1 plus F2 plus F3. Okay. So what is this equal to? This is equal to 176. So is equal to 1 minus 176 upon 1024. This is going to give me 1024 minus 176 upon 1024. What is the value? How much is that? 1024 minus 176 is 848. 848 divided by 1024. 828. This is equal to 848 upon 1024 is equal to 0.82. Okay, 0.828. Okay, so this is the second part. First part is 4 heads. I just put if x is equal to 4, I find the answer. At least 4 head means 4 and more than 4. So it is 1 minus 4. So this is 1 is the same. Then at most 3 is uh, at most 3 heads is 0, 1, 2, 3. Okay, now this third is very simple because I've already calculated 0, 1, 2, 3. Okay, I've already calculated how much is that equal to. See, the third answer you can get from here itself. So the third answer is 176 upon 1024. Third answer is equal to 176 upon 1024. At most 3 heads is 0, 1, 2, 3, which I've already calculated. This is equal to 848 upon 1024. And this is equal to 210 upon 1024. Okay. I hope this is clear. Excellent. M. Gowda is answered. Yes, Saloni. Very good. Manas, yes, Manas. Okay, Vaideh, what you can do is you don't know factorials. So what you can do, you can see the my lecture on permutation and combinations. Okay, and there everything has been explained very in detail. You can even download the PDF from the LCC website. Khushi, it is not whether you want to write in decimal or not. You are having an MCQ question paper. Okay, so you have to see what option. If the options are in decimals, you will take the decimal. If the option are in fractions, you will take the fractions. Okay, just look at what the answer in which format it is, and similarly you will have to write. Okay, and also remember that sometimes it does happen that you are suppose like in this case you have got 0.828 on the calculator, you are getting this, but in the option they have written like 848 upon 1024. How do I know that? Then I will, whatever options are A, suppose this is A, then for B you have 948 upon 1024. So do this calculation on your calculator. You will see this is equal to 0.828, while this is equal to, let me check how much is 8. 948 divided by 1024, 92. Okay. So you will see this answer matches with this. So this will not be the correct, this will be the correct answer. Okay. Yes, Akshi is saying clear, Saloni clear, Kushi clear, Varun clear, Asha clear. Yes, Om clear, Amar. Yeah. If 15 dates are selected at random, what is the probability of getting 2 Sundays? What is the probability of getting 2 Sundays? Yes. Now, probability of getting a Sunday. What is the probability? How many days in the week? Days in the week are 7. Okay. How many Sundays? 1. Okay. How many Sundays are there? 1. How many days in the week are there? 7. What is the probability of getting a Sunday? It will be 1 by 7. How we wish there were more than one Sunday, but that is not the case. You have one Sunday for 7 days. In 7 days, you will get one Sunday. So, probability of getting a Sunday will be 1 upon 7. Okay, so because sometimes, directly it is written 1 by 7 and you don't realize where it has come from. So, days in the week is 7. How many days, Sundays is? There is 1. So, 1 upon 7. Okay. Now, I have 1 upon 7. Now, what is this? This is P. P is equal to 1 upon 7. N is equal to 15. 15 days are given. What they are asking, what is the probability of getting 2 Sundays? Okay, 2 Sundays. So, X is equal to 2. Okay. So, we will have f of 2 is equal to 15C2 1 by 7 raised to 2 and 6 by 7 raised to 13. Okay. I'll write down the formula. Fx is equal to ncx p raised to x q raised to n minus x. Here n is equal to how much? 15. X is equal to 2 because I want 2 Sundays. P is equal to 1 by 7. So q will be equal to 1 minus p, which is equal to 1 minus 1 by 7, which is equal to 6 upon 7. Okay. So I have this. So what will this be? So I have just substituted here. F of 2 is 15C2, 1 by 7 raised to 2, 6 by 7 raised to 13. So this is equal to 15 factorial upon 2 factorial into 13 factorial into 1 by 7. So I have 6 raised to 13 upon 7 raised to 15. Okay. So either they will write the answer like this or like this, or they will solve this. This is equal to 15 into 14 upon 2, 6 raised to 13 upon 7 raised to 15. So, which is equal to, this is 1 7 7, this is 105, 6 raised to 13 upon 7 raised to 13. Okay. So, you may have in either of the ways the answer will be presented. Okay. So, you cannot take P equal to 2 by 15. Okay. Why? The thing is, they are asking you to find the probability. Okay. What is the basic structure? Basic structure is 1 week. And in 1 week, how many days are there? 7. And what is the probability of getting a Sunday in a week is 1 by 7. So using that, we are like building the probability distribution. It is not simple 2 upon 15. Okay. That is not the case. Because if I start on a Sunday, things will be different. If I start on Wednesday, things will be different. So within this 15 days, what is the probability? This is the probability of getting 2 Sundays. Okay. Chanchal, you are saying? Chanchal, I'll just write down your question. We have run out of time today, but I will take it up next time. So what are the questions? Chapter 15 question. Example you want? Example 20, 21, 22? Just see if I've opened this. Okay, you want probability, right? Just let me see. You want from the exercise, or you want let's say example, solved example? Just let me know, Chanchal. हाँ विदुषी, 7 की पावर तो 15 होगी, मैंने लिखा है ना 15 वहां पे। एक मिनट देखती हूँ। Yeah. Okay, Vidushi, this Chanchal, you want 21, 20, 21. Okay. Yes, next time I will explain this. No problem with that. Yes, in the last place. Here I've written 15, no? So 6 by 7 raised to 13, and here it will be 15. 6 raised to 13 upon 7 raised to 15, 6 raised to 13 upon 105, 6 raised to 15 upon 7 raised to 15. Okay. Okay, this is the last sum that I would like to take before doing this. Find the probability of a success of a binomial distribution satisfying the relation p x raised 4 p x is equal to 4 is equal to p x is equal to 2, having the parameter n as 6. Okay, so n is given to you as 6. 4 times p of x of 4. P x of 4 is equal to 6c4 p raised to 4 q raised to 2. Okay, 6 minus 2. Why? Because what is the formula that I have? NCX p raised to x q raised to n minus x. Okay, so 6 minus 4. Okay, so what will this be? So this 6c4 is 6 factorial upon 2 factorial into 4 factorial. P I don't know. P raised to 4 q raised to 2. Okay, this is equal to 5 and 6. This is 15 p raised to 4 q square. Okay. Now P2 is how much? P2 is 6c2 p raised to 2 q raised to 4. Okay. Now you remember NCR is equal to NC n minus R. Okay. You know this. So 6c4 and 6c2 will be same. That is 15. So P2 is how much? 15 p square q raised to 4. Now I put in the equation 4p4 is equal to p2. So 4 into 15 into p4 q square is equal to 15 p square q4. Okay. If I simplify this 15 goes off. Then I will be left with 4p square is equal to q square. Okay. 4p square is equal to q square. Taking square root, what will I get? Taking square root will be 2p is equal to q. 2p is equal to q. I also know p plus q is equal to 1. So p plus 2p is equal to 1. Instead of q, I am writing 2p. Instead of q, I am writing 2p. So this is equal to 3p is equal to 1. So p is equal to 1 by 3, or q is equal to 1 minus 1 by 3 is 2 by 3. Okay. What have they asked? Find the probability of success. So they just want probability of success. Probability of success is 1 by 3. We check. Yes. Is equal to 1 by 3. Okay. Also remember, this is important that you understand, when I take square root, I may even get a negative number. When square root is taken, I get a negative also. But probability is always greater than or equal to 0. So you cannot have a negative number. Okay. So therefore P is 1 by 3. For a binomial distribution for which mean and standard deviation are 6 and 12, 6 and 2 respectively. Okay. So I think you all are tired. Okay, don't worry, don't worry. So this is very simple in the sense that mean is equal to NP is equal to 6. Standard deviation is equal to square root of NPQ is equal to T. That is variance is equal to NPQ, which is equal to 4. Okay. So from here what I can do, mean upon variance is equal to 6 upon 4, which is equal to NP upon NPQ. Okay. So this NP cancels. This is 3 and this is 2. So Q will be equal to 2 by 3. And P will be equal to 1 minus 2 by 3. It will be 1 by 3. Okay. Now if I have this, P is 1 by 3, mean is equal to NP, which is equal to N into 1 by 3, and which is equal to 6. It is given, mean is 6 is given. So N will be equal to 6 into 3, which is equal to 18. So what is my binomial distribution? My binomial distribution is N into P, N comma P, which will be equal to B of 18. And what is P? 1 by 3. So it will be 1 by 3. Okay. Even like if you want to write it also, you can write it as 18CX 1 by 3 raised to x and 2 by 3 raised to 18 minus x. Okay. So either way, whichever format they have given you, you should be able to answer. Okay. So these are the wonderful ways in which you do it. Okay. This fitting of a normal distribution, okay, we run out of time. Okay, I will take this and I will take a Poisson also next time. Okay, I'll just see if I can get an extra lecture. Then we could, otherwise I will have to also finish normal distribution in the next session. Okay. So thank you all for your patient hearing. Have a great day ahead. Yes. Thanks a lot, Ruhani. Thanks a lot. Yes, Om. Thank you. Close करें.